B. What's the probability that the score is 1 given that the player does not lose? Score is 1 means x equals to 1, probability x equals to 1. Then given that player does not lose. So it means eventually he got a 6 lah. Also x is equals to 1 means the number of toss it takes for the player to toss the first 6. That means he took 1 toss to get 6. So hence right, the numerator for conditional probability A given B is equals to probability A intercept B over probability B. So hence x equals to, the numerator will be probability x equals to 1 intercept the event the player not lose, which means that player not lose means eventually he got a 6, right? So x equals to 1 means he took 1 toss to get a 6. So over probability that player not lose. No, so because the denominator is the probability of the given event. So equals to, okay, so if for the player not lose, for the first part, right, probability x equals to 0 is 0 if the player loses the game. So this one is the probability of lose game. If it's not lose, that means right, probability not lose game will be 1 minus probability lose the game, right? That's the denominator. Then numerator, 1 toss and got a 6. That means right, it's just probability of getting a 6 in 1 toss is the numerator. So that means to get a toss, the 6 in 1 toss, the probability is 1 over 6. So it's equals to this. So 1 over 6 minus over, okay, 1 over 6 over 1 minus the probability of losing a game, which is 3/4. So that will be the answer to part B. Okay, so to get the answer to part, I can simplify by multiplying 24, the lowest common multiple of 6 and 4. Then you simplify quickly. 24 divided by 6 is 4. 24 minus 6 times 3. 24 minus 18, so it's 6. So we have 2/3. Okay, so that's the probability of score is 1 given player does not lose. The next part is known that P is between 0 to 1. It is known that if the P is between 0 to 1, then this is equals to this and this is equals to this. This is the results that we can use for finding EX and variance X. Let's get the probability distribution for all the possible X values. So probability X equals to X. This is called the probability distribution table. The probability of losing is 3/4, which we already found. Then when the probability of X equals to 1, we found that it is just 1 over 6. That means getting the 6 in 1 toss. Or to get the 6 in the second toss, it has to be 2 or 4 in the first toss, because that's the only way it can continue, right? If the number is according to the question, to continue it has to get 2 or 4. If it got odd, then it will lose, right? So that is half is this probability of this. 2 or 4, the probability is 2 over 6, which is 1/3. And then the 6, to get a 6, right, that means winning, that is the probability is 1 over 6. So to win in the second toss, right, the X is number of toss it takes to toss 6. So to win in the second toss means first time he got 2 or 4, so that he can continue to get a 6 in the second toss. So it's this is the probability of this is 1 over 6, right? So I think to be more consistent, you should write the here. So then it will continue, and then the probability of this is 2 over 6. Okay. Then hence the answer to this is 2 over 6 times 1 over 6. How about for 3? Or that will be, that means continue twice and win again. So then 4 will be the first 3 times you get 2 or 4, so that you can continue 3 times, and then the 4th time will win, right? So on and so forth. So it will go on and on forever. So if I want the expectation of x, right, the formula for expectation of x is equals to summation the x times the probability of that value x. So where x equals to I equals to 1, then in this case, right, because x, where x equals to 1 to infinity, in this case, right, the x can be at infinite, right? Suppose we keep tossing even, like the 2 or 4 forever, right? It's possible, right? Never ending the game. So that's why the ending term is infinite. Then these symbols means that we'll take x times its probability plus take this x times the probability of, then this plus this 2 times 2 over 6 times 1 over 6 plus 3 times the 3 times this one 2 over 6 square times 1. But I cannot keep on writing this forever, right? So this one is just 0. All the rest of the term has a common factor 1 over 6, so I factorize 1 over 6. Then the remaining terms is 1 plus 2 times 2 over 6 plus 3 times of 2 over 6 square plus the next one will be 4 times of 2 over 6 cubed. The pattern will continue on, right? Then if I were to write it in summation notation, then this number I can also write it as 1 times 2 over 6 to the power of 0, because anything to the power of 0 is 1. The reason why I want to write it this way, right, so that it's consistent. 1, 2, 3, 4, then the power of 2 over 6 is 0, 1, 2, 3, so on and so forth. So that it's easier to see that the pattern can be written as r equals to 1 to infinity, because there are infinitely many terms here. Then 2 over 6 to the power of, when r equals to 1, right, the power is 0, so the power is r minus 1. When r equals to 2, you see the power is 1. When r equals to 3, power is 2. So the power is always 1 less than the number here, right? And it starts from, r starts from 1. So this is what the symbol means. Okay, so I cannot go deep into the summation notation here, but if you're interested, you can approach me for a lesson on summation notation. So equals to, from here, right, then do you realize that what we have here, right, is very similar to the expression here. You see p to the power r minus 1. So in this case, right, our p will be the 2 over 6, right? Then the rest, r equals to 1 here, you see r equals to 1, infinity, then infinity, r, then r, then p is the 2 over 6. So in other words, to use the formula above given to us over here, I just need to substitute the p with 2 over 6. But there's a 1 over 6 in front, so I write 1 over 6 first. Then we have a multiply by 1 over 1 minus 2 over 6, because the p is the 2 over 6 in this, but in our case, right, in this case. So, and square, and then you would get the expression here. Then the next part, to get variance x, right, the variance x, I leave it, okay, for this part of question, I will leave it to the next video. Variance x is equals to ex square minus the ex bracket square. So since we have already obtained the ex here, which is this one, we just substitute into here, right, and square it. That's what. But for how about for expectation of x square, right? Expectation of x square is just equals to, when you multiply, instead of 0 multiplied by 3 over 4, is 0 squared times 3 over 4 plus 1 squared times 1 over 6 plus 2 squared times the probability, which is 2 over 6 times 1 over 6, so on and so forth, right? And it goes on forever. So the only difference between ex and ex squared is that now, instead of multiplying by the x value, the probability multiplied by x value, we take the probability multiply the square of the x value and then add up. So you can guess that in order to evaluate this, we need this summation formula over here, right? So you can try it out yourself and see whether you can get the answer. Thank you.